Welcome dear students in the third video of refraction through a lens. In this video I am going to explain about sign convention and lens formula. So let us start first sign convention. There are 3 points in this we must have to remember. The first one is that all the distances are measured from the optical center. That is, see in this figure, in this ray diagram, the object is placed between focus and radius of curvature. The image is formed on the other side beyond the radius of curvature. Now, beyond the center of curvature. Now, let us see, as I said, all the distances are measured from optical center. Means, we will measure the distance OA. That is the image distance. Sorry, object distance. So, object distance is OA. O to A, as AB is the object. So, object distance, optical center to the point A. Image distance. This object distance is measured by OA and it is denoted by U. Next, image distance. Image is A dash B dash. So distance we measure from optical center to A dash. So OA dash is the image distance and it is denoted by V. Focal length. Focal length OF2 or OF1. So it is denoted by F. Radius of curvature is denoted by R, that is O2 to F2. Height of object, this is this AB. Next one is height of image, that is A dash B dash. So first rule I said, all the distances are measured from the optical center of the lens. Now second rule. The distances measured in the direction of incident ray, in the same direction of the incident ray, that are taken as positive, and the distances measured opposite to the direction of incident ray are taken as negative. It means the distance O to A dash. See, the ray incident from the object in this direction means from left to right. So all the distances from left to right, that means in the direction of incident ray, are taken as positive, and the distances measured opposite to the direction of incident ray means to the left side of this optical center will be taken as negative, as the ray is incident from left to right. So the distance OA means object distance will be negative, as it is in the opposite direction of incident ray. Image distance O to A dash will be positive, as it is in the direction of incident ray. Focal length OF2 will be positive. So for convex lens, focal length will be positive, and for concave lens, the focal length will be negative. See, if we will see for concave, the ray principal axis this is, if a ray of light incidents, it diverges, and if we will produce in the backward direction, then focus is this one, optical center this. So we are measuring in the direction opposite to the incident ray. So focal length for concave lens is negative, and for convex lens will be positive. Radius of curvature will be positive for convex and for concave negative. So this is the second rule, that all the distances measured in the direction of incident ray are taken as positive, and the distances measured opposite to the direction of incident ray are taken as negative. Next one, the distances measured upward and perpendicular to the principal axis are taken as positive, and downward and perpendicular to the principal axis is taken as negative. So this distance AB, that is the height of object, is taken as positive, and height of image, that is h dash or length of the image, will be taken as negative. So there are three rules. What I said, once again I am telling, all the distances we measure from optical center first. Second one, the distances measured in the direction of incident ray are taken as positive, and in the direction opposite to the incident ray are taken as negative. Third, the distances measured perpendicular to the principal axis and in upward direction is taken as positive, and downward to the principal axis is taken as negative. Now next term we will say, that is lens formula. So lens formula. What is this lens formula? It is a relationship between image distance V, object distance U, and focal length of the lens. The lens formula can be written as 1 by f equals to 1 by v minus 1 by u. This is the lens formula, where f is focal length of the lens, v is the image distance of the lens, and u is the object distance of the object distance. So this formula we can use for both, that means concave as well as convex lenses. Next term we will say, that is linear magnification. So what is linear magnification? It is denoted by small m, linear magnification, and it is the ratio. Linear magnification is the ratio of the height of image to the height of object. That is, we can write m is equals to h dash by h, where h dash is the height of image and h is the height of object. We can also write linear magnification is equals to v by u, where v is the image distance and u is the object distance. So this is the relationship. Now, if the value of linear magnification is positive and less than 1, it means the image formed is virtual and smaller than object. It can happen in the case of concave lens. As we know, concave lens forms the images which is smaller than the object, and virtual image it forms, that is erect image. So the magnification for concave lens will be always positive but less than 1. In case of convex, if the magnification is positive, then it will be greater than 1. As we know, when the object is placed between focus and optical center, the image formed by convex lens is highly magnified and virtual image. So if h dash will be greater than h, m will be greater than 1. And as I said, virtual image, so erect, it means upside the principal axis. So magnification produced by lens is positive and greater than 1. It means it is a convex lens and object is placed between focus and optical center of the lens. In other positions, like convex lens forms real and inverted image. So if the image formed is negative, if the magnification is negative, it means the image is formed by a convex lens. So this is all about linear magnification. Next term we will say, that is power of lens. So what is the power of lens? Power of lens. Power of lens is the ability of a lens to converge or diverge the refracted ray. Let us see how. If I am using two lenses, let us see first. Suppose I am taking two convex lenses, one is thick and one is thin. This is the principal axis. A ray of light incident on it and it converges, it bends like this, and in this the ray of light is bends like this. So look at this lens 1 deviates the ray of light more than the lens 2. So we can say the power of lens 1 is more than the power of lens 2. So power of lens is the measure of deviation produced by a lens after refraction in case of both concave and convex. We can also define, or we can say, the power of lens is the ability of a lens to diverge or converge the ray of light. Next one, we can also define power of lens as, power of lens is the reciprocal of focal length of the lens in meter. So P is equals to 1 by F, and F always we use in meter. This is the mathematical formula or expression for power of lens. If focal length will be positive, then power will be also positive. If focal length will be negative, power will be also negative. It means in case of convex, the power will be positive, and in case of concave, the power of the lens will be negative. This power of lens, the SI unit of power of lens is SI unit of power of lens. We denoted the power of lens as SI unit D, diopter. So what is 1 diopter? So SI unit of power of lens is diopter. Let us define 1 diopter. 1 diopter is the power of lens, or power of lens is said to be 1 diopter if its focal length is 1 meter. If the lens having its focal length 1 meter, then we can say the power of that lens is 1 diopter. So this is all about sign convention, lens formula, linear magnification and power of lens. Thank you students. Thank you for watching.